Assalamualaikum warahmatullahi wabarakatuh. Before the discussion, introduce myself, Ilmi Solihah, with student number 21-11-046. Here, I will present an undergraduate thesis from one of my seniors, which is certainly related to my major, civil engineering. The topic discussed is about soil. The title of his research is Soil Nailing Analysis on Cigunung Singajaya Garut. This research authored by Champernik Tarakashima. Related topics that will be discussed in this presentation are: first, about the introduction; second, about the problem of conducting research; third, the method used to overcome the problems that occur; fourth, there are research results; fifth, there are research implications; and the last is the conclusion of the research conducted. Let's go straight to the introduction. Yes, introduction. In this research, it is discussed about what is landslide, which is closely related to soil. Why? Because we all know that there is no landslide that does not occur on the ground or on the ground. Of course, landslides always occur on soil material, not other than soil. Landslide is a part of land movement where there is a displacement of soil or rock mass in vertical or horizontal direction that occur in the condition of steep slope area, high humidity, open land, or unstable soil. The purpose of this research is to determine the safety value of the slope and plan reinforcement that can increase the safety value of the slope. This is done to provide safety and comfort to the local community. The next is about the problem of what happened. In the introduction part, it is discussed about landslide disaster, where in this research, the case study taken is in Garut, West Java. Based on the detection result, Directorate Jenderal Vulkanologi and Mitigasi Bencana Geologi, DVMBG of Garut area, the sensitive zone that can cause landslide is in the highlands, covering Banjarwangi, Singajaya, and Pendai areas. The landslide that occurred on the slope of Cigunung, Girimukti, Singajaya, Garut result in the cutting of 35 meters long road access with a depth of 20 meters to Cihurib sub-district. Based on this condition, a contraction technology that can improve and strengthen the slope is needed. Then the research method. In this research, the method used is quantitative and descriptive by modeling the object under study. In the slope stability analysis, Bishop method and finite element method were used using GeoStudio Slope or W-Student version program. The Bishop method works on the principle of limit equilibrium by calculating the shear strength that maintains the stability of the slope compared to the magnitude of the applied shear stress. The finite element method is used to transform the whole object, in this case the Cigunung slope, into small parts and then solve the differential equation by converting it into a system of algebraic equations. Reinforcement of slopes with soil nailing uses variation in slope angles of 10 degree, 15 degree, and 20 degree, and variation in the length of nailing rods with the same number, namely 18 meters, 10 meters, and 12 meters. Soil nailing is a method that combines passive reinforcement of steel bars and shotcrete. In soil nailing, steel pieces are embedded into the soil. degraded to improve the stability of the slope or retaining wall. This method is effective to overcome stability problems on slopes that have landslide potential, such as the slope of Cigunung Singajaya Garut. The slope stability analysis using the finite element method in this study used geostudio slope or risk identification with parameters such as soil data, slope design, safety vector, reinforcement diameter value, nail tensile value, and adhesive strength value. Then analyzes Bishop method to determine the safety vector value approach using Palanis value. Result for the research. The result of the Bishop method analysis obtained a slope safety vector value of 0.273 less than 1.5, which means the slope is unstable. While the result of the analysis using the finite element method, figure on the side, result in a slope safety vector value of 0.201 less than 1.5, which means the slope is unstable. Both Bishop's method and finite element method analysis result in a vector of safety value smaller than the allowable value of 1.5. Therefore, the slope requires reinforcement. Strengthening the slope with the soil nailing method model into two types of nail bar inclination angles and the finite element method analysis result in a vector of safety value of 1.286 for a nail angle of 10 degree, 2.195 for a nail angle of 15 degree, and 1.540 for a nail angle of 20 degree. Implications for the research. First, slope safety assessment. This study aims to determine the slope safety value and find the reinforcement that can increase the slope safety value. Soil nailing was used as the reinforcement method. And second, variation of slope angle and nail bar length. This study considered variations in slope angle 10 degree, 5 degree, and 20 degree. In nail bar length 8 meter, 10 meter, and 12 meter. The slope stability analysis results show different factors of safety for each angle variation and nail bar length. Next, conclusion. First, slope stability before reinforcement with Bishop method analysis obtained a safety vector value of 0.273 and analysis with the finite element method obtained a safety vector value of 0.201. And second, the safety vector value of the slope after being reinforced with soil nailing at an angle of 10 degree is 1.286. Soil nailing at an angle of 15 degree is 2.195, and soil nailing at an angle of 20 degree is 1.540. The soil nailing angle variation that has the large factor of safety value is 15 degree. References. As for research references, for undergraduate thesis only available at the Garut Institute of Technology library, but for journals there are links that have been listed and published in the journal Konstruksi of the Garut Institute of Technology, which has received the Sinta for predicate. That's all the presentation on the assignment give. Hopefully this video is useful, especially for me personally. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.